Are you puzzled by the concept of structural isomerism? Does it seem like a daunting topic that you just can't wrap your head around? Well, you're not alone. Many students find this topic challenging at first, but with the right approach it can become one of the most interesting and rewarding parts of organic chemistry. Structural isomerism is a fundamental concept in organic chemistry that deals with compounds having the same molecular formula but different structures. This means that even though the compounds have the same number and type of atoms, the way these atoms are arranged in space is different. This difference in arrangement can lead to vastly different chemical and physical properties, making structural isomerism a crucial topic to understand. Don't worry, we've got your back. Let's make it a breeze. Imagine you're building different models using the same set of Lego bricks. You can create a car, a house, or even a spaceship all using the same pieces. Similarly, in structural isomerism, the same set of atoms can be arranged in different ways to form different compounds. This is what makes structural isomerism so fascinating and important. Structural isomerism is all about compounds having the same molecular formula but different structures. Think of them as different Lego models built from the same set of bricks. There are several types of structural isomers, but let's focus on the three key ones. First, chain isomers. These differ in the carbon chain arrangement. Picture butane and isobutane. Both have 4 carbons but are arranged differently. Chain isomers are perhaps the easiest to understand. They differ in the way the carbon atoms are connected to each other. For example, butane and isobutane both have the molecular formula C4H10. But in butane, the carbon atoms are arranged in a straight chain, while in isobutane, the carbon atoms form a branched chain. This difference in structure leads to different properties such as boiling points and reactivity. Next up, position isomers. Here the functional group remains the same, but its position changes. Imagine moving a flag on a map. The flag stays the same, but its location varies. An example? 1-butanol versus 2-butanol. Both are alcohols, but the OH group moves. Position isomers are interesting because they can have very different properties even though they contain the same functional group. For instance, 1-butanol and 2-butanol both have the molecular formula C4H10O, but in 1-butanol, the OH group is attached to the first carbon atom, while in 2-butanol, the OH group is attached to the second carbon atom. This difference in position can affect properties like boiling point, solubility, and reactivity. Finally, functional isomers. These have the same atoms but different functional groups. It's like transforming a car into a boat using the same parts. Consider ethanol and dimethyl ether. Same formula, but one's an alcohol, and the other's an ether. Functional isomers are perhaps the most intriguing because they can have completely different chemical properties. For example, ethanol, C2H6O, is an alcohol and is commonly used as a solvent and in alcoholic beverages, while dimethyl ether, C2H6O, is an ether and is used as a propellant in aerosol sprays. Despite having the same molecular formula, their different functional groups give them very different properties and uses. So remember, mastering structural isomerism is all about recognizing these differences. Keep practicing, and you'll be ready to ace your GE. You've got this. Understanding structural isomerism is not just about memorizing different types of isomers, but about understanding how the arrangement of atoms affects the properties of a compound. This understanding will not only help you in your exams but also in your future studies and career in chemistry. Let's delve a bit deeper into each type of structural isomerism. Chain isomers, as we mentioned, differ in the arrangement of the carbon chain. This can lead to differences in physical properties such as boiling points and melting points. For example, straight chain alkanes generally have higher boiling points than their branch chain counterparts. This is because straight chain alkanes have a larger surface area, leading to stronger van der Waals forces between the molecules. Position isomers, on the other hand, have the same carbon skeleton but differ in the position of the functional group. This can affect both physical and chemical properties. For example, the position of a double bond in an alkene can affect its reactivity. In general, alkanes with double bonds closer to the end of the carbon chain are more reactive than those with double bonds in the middle of the chain. This is because the electron density around the double bond is higher at the ends of the chain, making it more susceptible to attack by electrophiles. Functional isomers are perhaps the most diverse group of structural isomers. They have the same molecular formula but different functional groups, leading to completely different chemical properties. For example, consider the compounds propanol and acetone. Both have the molecular formula C3H6O, but propanal is an aldehyde, while acetone is a ketone. Aldehydes and ketones have different reactivities and are used in different types of chemical reactions. This makes functional isomerism a particularly important concept in organic chemistry. To master structural isomerism, it's important to practice drawing and identifying different types of isomers. Start by writing out the molecular formula of a compound, and then try to draw as many different structures as you can that fit that formula. Pay attention to the different types of isomerism, and make sure you understand how each type affects the properties of the compound. With practice, you'll become more comfortable with identifying and drawing structural isomers. Another useful tip is to use molecular models. These can help you visualize the three-dimensional structure of a compound and see how different arrangements of atoms can lead to different isomers. Molecular models are particularly useful for understanding more complex types of isomerism, such as stereoisomerism, which we'll cover in another video. Finally, don't be afraid to ask for help if you're struggling with structural isomerism. Your teachers and classmates can be valuable resources, and there are plenty of online resources and tutorials that can help you understand this important concept. Remember, the key to mastering structural isomerism is practice and persistence. Keep at it, and you'll get there. In summary, structural isomerism is a fascinating and important concept in organic chemistry. It involves compounds with the same molecular formula but different structures leading to different properties. There are three main types of structural isomerism: chain isomers, position isomers, and functional isomers. Each type of isomerism affects the properties of a compound in different ways, making it crucial to understand and recognize these differences. By practicing drawing and identifying different types of isomers, using molecular models, and seeking help when needed, you can master structural isomerism and be well prepared for your GE exams. Remember, understanding structural isomerism is not just about memorizing different types of isomers, but about understanding how the arrangement of atoms affects the properties of a compound. This understanding will not only help you in your exams, but also in your future studies and career in chemistry. So, keep practicing, stay curious, and don't be afraid to ask questions. You've got this. With dedication and hard work, you can master structural isomerism and ace your G exams. Good luck. So remember, mastering structural isomerism is all about recognizing these differences. Keep practicing and you'll be ready to ace your GE. You've got this. Understanding structural isomerism is not just about memorizing different types of isomers, but about understanding how the arrangement of atoms affects the properties of a compound. This understanding will not only help you in your exams, but also in your future studies and career in chemistry. So remember, mastering structural isomerism is all about recognizing these differences. Keep practicing, and you'll be ready to ace your GE. You've got this. Understanding structural isomerism is not just about memorizing different types of isomers, but about understanding how the arrangement of atoms affects the properties of a compound. This understanding will not only help you in your exams, but also in your future studies and career in chemistry. So remember, mastering structural isomerism is all about recognizing these differences. Keep practicing, and you'll be ready to ace your GE. You've got this. Understanding structural isomerism is not just about memorizing different types of isomers, but about understanding how the arrangement of atoms affects the properties of a compound. This understanding will not only help you in your exams, but also in your future studies and career in chemistry.